Hello, it's Duncan. Kent Beck has been writing recently on the idea of the adjacent possible and software design. The adjacent possible is a technical space where we can reach from where we are now in one hop. We don't have to develop something intermediate before we can implement something useful. In software, sometimes we add some code and find ourselves expanding the adjacent possible. I think that happens in this episode. I was just adding the ability to discard coroutine continuation parameters when we call one interface or another, but on refactoring that code to remove duplication, I think I've uncovered a technique that will allow us to implement the decorator pattern for interfaces by populating maps of functions. So now we've got an interesting shape. We build something that allows us to exchange a method of something to call. I'm on a bit of a mission at the moment, and that mission is to compare HTTP4K and Ktor as web servers. And in particular, I want to measure their throughput. And my plan is to measure it for a Ktor example app that I've ported to HTTP4K. As part of that port, we've ended up with this interface here, this customers interface, which is a repository for customers' data. And we have routes mapping to list customers and find them by ID and so on. And we have an in-memory implementation of that customers interface using a mutable list. In reality, of course, the customers will almost certainly be stored somewhere external to this process, and so accessed over the network. And so I've also created this co-customers here, which allows the functions to be suspend functions so that we can efficiently call them from Ktor. Now we end up with the problem that we may be able to efficiently call them, but we can't efficiently define them in terms of this in-memory customers that we already have. The problem is that these functions here are not suspend functions, whereas these ones are, and slightly irritatingly, we can't implement a suspend function with a non-suspend function. And the issue we discovered is they have a different signature. These suspend functions actually have a hidden continuation parameter passed to them. I have got most of the way there in solving this problem though, and you can see it in this structural typing tests. And here you can see we wrote this structurally typed as that allows us to act as if an object is wrapped here, which is a list, implements another interface, in this case our myCollection. So list of does have methods called size and get, and our structurally typed as creates a new Java proxy instance that maps calls to this interface here to called on our list. We had about the usual number of issues getting this reflection to work, but it does seem to be solid. So let's see whether we can get this working with suspend functions. Fold that away, and I think we'll duplicate this test, but we'll change it and we'll say calls methods with matching name and signature, ignoring suspend. So let us create a collection, but we'll call this my co-collection for coroutines. And we'll make this suspend, and we'll make this suspend. And I'm going to add in another one that isn't suspend to keep us honest. So collection has is empty, so we'll add in fun is empty, that returns boolean, but isn't suspend in this interface. Now what we want to do is structurally type as my co-collection. And you can see here as soon as we do that we can't call size or get without a coroutine context, but we could call set equals false wrapper dot is empty would be fine because that's not a suspend function. Now there is a test coroutine context I think we can get with run test. I have to import that? No, I guess I have to find it in Gradle. Hold on. Okay, there we are. That was only 10 minutes. It was that long because it turns out that Kotlin X coroutines tests version is not the same as the Kotlin version. It is currently 1.9.0-RC. Jolly good. So now we have this run test. It sets up a coroutine context that allows us to call this wrapper size and wrapper get that are suspend as down here. Let's run this. And what we see is we have an error which says that we can't find Java lang object myCollection size complete with a Kotlin coroutines continuation parameter. So that's the hidden parameter that is in here, but we can't see it, and means that when we're looking for a method with the same signature, this size, on our array list, this one, we don't find it. So, however we solve this problem, I don't think we want to pollute and current structurally typed as with it. So what I propose to do is say that we want this only to work when we call co-structurally typed as, and then let's come over here and we would duplicate our structurally typed as to give us a co-structurally typed as. And as that was calling this structurally typed as here, and this is doing all the work looking up, I think we're going to need another version of this. So let's duplicate this as well. And we will call this any.co-structurally typed as, make this one call that one. And now let's pull this down into here so they are together. And run. And in fact, I'm going to run all the tests to make sure that we only fix and break the thing that we think we're fixing and breaking. Good, one thing not working. Okay then, here's where we build the lookup, and we're looking in all of our types for a method matching the proxy method. That is to say, the one with this extra parameter in here. I think the easiest thing for us to do is just going to be to say, if we see a last parameter of this coroutine continuation, then look for a matching method without it. Now that's a little bit of a problem because we'd need to build a method in order to call method matching, and we can't actually build methods ourselves. But if we look in here, we are actually checking for a method with a given name and parameter types. So I think if we were to pass not the method but the name here, call that method name, and same thing here, parameter types. You can see the method parameter has been deleted. And I think we can then change the signature of this so that we'll move that can access down like that. So that will have changed both our co-structurally typed as and our structurally typed as, but allow our co-structurally typed as to ask a question about different parameter types. Are you with me? Okay, so let's fold that away for now and have a look at this. In here, for each of our proxy methods, we can say val is suspend is proxy method dot parameter types dot last or null. Now what type should that be? Well, it's the one that failed our tests. So let's go and look in the run, and here it is. We were getting a Kotlin coroutine continuation parameter. So if we take that and put it in there and say we are a suspend function if we are seeing our last parameter exists and is continuation class. I suppose there might be pathological cases where you might pass a continuation and not be a suspend function, but I think this is good enough for engineering purposes. So now we can say val parameters to consider is when we are suspend, we want to remove the last one. So that will be proxy method parameter types drop last one, and as that will be a list, we need to say to typed array. And this is the case for true, and the case for false is that we want to be the proxy method parameter types with no changes. And then put those into there. Let's run that. And now here we have succeeded in creating a lookup. The only problem is that when we actually come to call the method, we're giving it the wrong number of arguments, because our proxy will be called with the coroutine context, but it won't be discarding it. It will be passing it to our method, which will then be getting one more argument in this case than it expected. So we have to fix up the place where we call as well. And I think we can write similar code. So here we can say it is suspend in here if the args last or null question mark dot Java class is continuation. Then we can say val args to pass is when is suspend true. Well, again, we want to drop the last one, else we want to pass all the args. There'll be a little bit of jiggery pokery over the fact that args may come in as 0, so I think maybe we need to say args question mark dot last or null. But now in here, I think maybe we can just use args to pass. What do you think? Oh, idiot, that should be drop last. Try. No. Tiny bit of debugging shows that that last argument is a subclass of Kotlin coroutine continuation, not actually it. So instead of asking for the class, we'll ask, is it a continuation? And we're good. Okay, then let's step back and have a look at this. It may work, but it really is hard to see what's going on. There's also all this duplication with this other version up here, which does the same thing, but without the messing around with the last continuation parameter. So the question is, what is trying to get out of this duplication and this mess? Now remember that all this mess down here is because we're looking up a method in order to invoke it, but we can't change what happens when we invoke a method. They are built into the JVM in some sort of sense. If we could, then we could move this logic here from when we're invoked to when we create the thing that we want to invoke. And that's the point at which we know whether we are a suspend function. So I had this cunning plan, which is to change the thing that we get when we look up a method here from method to something we can call, to a function type. Because if we do that, then we can move the logic from here to here. Does that make sense? Well, let's have a look. What I'm going to do is do it gradually because I could easily mess this up. I'm going to change the type of this, the thing in the map here, from just method to pair of method, and I'm going to make it unit for now. That will let me migrate from something to something else. And that then would mean that I need to yield this to unit to make that compile. Oh, irritating, it's this throws no such method, and let's just back that out a bit. Let's say that val method is that thing up to there, and we will return method to unit. A lot of this complication will go away in a minute. Okay, now what's in lookup is this pair, then we'll have to destructure it here. So in here we can say we'll get the first thing out of that and invoke it. Does that still work? It does. And now I'm going to change the type of this thing to something that we can invoke in this handler here. Now this handler takes a method and takes args, and that args is array of any. So I think here we're going to put in a function that takes array of any and returns any question mark. And we can resolve that with a function that's empty for now. Good. Now we want this lambda to do what this is doing. So it's going to take args, but it knows whether it's suspend because of the parameter types and not the arguments itself, like this. So we can take this code and put it in here, and that will bind to this is suspend. And now in here, we don't have to look up the method. It is this method. What we can say is method invoke this with our args to pass. We're not using it yet, so providing it compiles, it should work. Good. But now here we can cut over to using this lambda. So if we go to second, now our lambda only takes one parameter because of this we're already using there, so we can get rid of that. And we don't need to do this malarkey here because we've already done it in here. So I think this is going to be invoke with args or an empty array. And at this point, I think we can say, oh, any. Drum roll. Phew. So now you can see we don't have to ask whether this is suspend because that was dealt with up here when we created the thing we're going to call. So we can get rid of that. And now we can make this a map of method to just our function type. So this is array to any. And we can get rid of the method 2 in there. And this is a point where we do, for reasons, have to put a bracket, but we can get rid of that second. How are we? Splendid. Okay, before we go on, I think we just tidy this up a bit. This parameter types we keep on doing, so let's at least pull that out into a local to save us cloning it continually. And now we can see that this code here and this code here is effectively the same. It's taking an array and it's dropping the last one when a condition is true. So I think we should be able to take this thing and make a method out of it and call this drop last if. Now that's stopped compiling, but let's see whether we can make it work. What we can say is this is a function that takes of some sort of t, and this is then going to be an array of that t, and it's going to return another array of that t. And to make this typed array work, we need to know the actual type of t. That's a bit of a bother, but I don't think we ever really wanted to be doing that because drop last here is returning a list that we're then making back into a typed array that doesn't feel all that efficient. Let's ask what else we can do on an array. Ah, look, we've got copy of range. So I think that is parameter types copy of range from 0 to where the last index is the parameter types size -1. And now if we make this the receiver, and then this is not just is suspend, but is some condition. Don't think we need that question mark. And I think maybe we could get rid of the bit there and say when condition that else that. Go and see where we used it. So here we're saying parameters consider is parameter type drop last if is suspend. Well, we've tried running the tests, but we're still good. And so we can do the same thing here. We can say args to pass is args drop last if is suspend. Wonderful. And now I think it's reasonable to inline that. Rename this to be, I don't know what, matched method. Fix that after all this time. And that's rather cool. So now co-structurally typed as has a nice form. Basically, we do all the work up front in working out whether something is a suspend function, and if it is, how we have to munge it specially. And then we just go ahead here and look up something to call and call it. Well, that looking up something to call and then calling it is very similar, in fact, to what we did up in here. So I wonder whether we couldn't make them look the same. So in order to make them look the same, we will take this as the thing we're looking up, not a method now, but a function type. Inside this associate with, we're going to say this is our matching method. We will thunk from our matching method to a lambda in the same way, except that we don't want to get rid of the last arguments. And we just don't want to drop the last. And now in our proxy instance, we want to do exactly the same thing as this one here. So we'll take that and just copy it over the top of that code, which compiles and works. Good. So now we've got an interesting shape. We build something that allows us to exchange a method of something to call. Then we build a proxy instance that knows how to use that. So now let's separate them out. Let's take this thing and make a method out of it. Don't know quite what to call it yet. I think I'm just going to call it structural lookup. In fact, maybe structural lookup 4. And similarly, this here, from here down to here, would be co-structural lookup for proxy type. And now let's extract this common code here as proxy, but making this the receiver. That allows us to inline that in there. I think now this suppressed cast just needs to be moved down into there. And we can do the same thing in here. So structurally typed as is lookup.asProxy of my type. Inline that and remove that. Good. And now if we're happy for this to be public, then we can inline this. That's caused some issue here. As proxy also needs to be public. But I think we're now building blocks for building proxies, so we're going to have to make those public. Same thing here, we'll inline that, making co-structural lookup for public. A little bit more tidying here, make these into separate lines, join that, and inline that. Still good. Oh, and that has been sitting there for a while. In fact, that reminds me that we need not do this here. If we made this a map of method to nullable function type, so we'll put brackets around that and make that nullable, then we wouldn't have to do that there. Now the thing we put in the map is match method let that thing But now we've changed the type of this. Our as proxy isn't working. So where is as proxy? Well, it's here. Again, we can relax that to be a lookup that might return null. But the fact is, of course, any lookup might fail anyway because the right method might not be there. So because of this here, we don't have to change this at all. It will now just fail when we try and call the method rather than when we try and build the proxy. So that should make a test failure. And does. Let's have a look. It's the test we expected. Throws no such method error on creation if we can't find a match. So how do we get back that behavior? Well, we can do it in here now. We can say check all found. That doesn't exist. What would it look like if it did? It would be something like this. And we could make this generic, but let's actually make it on a very specific type. So we'll say that this is a function that takes a map that looks like that, returns a map that looks like that. And I suppose I might argue that this converts this type here into one where we know we do have a result. So we could take out that and that. Well, I won't bore you with the implementation of that. I've changed the tests here to show that we are actually populating the exception. But now this means I think that this one is strongly structurally typed as. So strongly structurally typed means that we check at the point where we create. But if we didn't do this check all found, then we don't check when we create. So why is that useful? Well, I suppose because we could say we take a version like this and we can not throw no such method error. So let's take the version that we haven't written yet, which is weakly structurally typed as. That is the same thing, just without this check. We saw that last time. And now in here, we could say, I'm going to say val thing is wrapped weakly structurally typed as my collection 2, the one that we had this no such that isn't implemented. But now we can say val implementation is an object which implements my collection 2 or string by that thing, which isn't going to check, but overrides no such to say return. Aha. And now, if we're right, then we can say assert equals aha is what we get by calling our implementation no such, but the rest will still delegate. So it will be true that 2 is our implementation size. Bad spelling of this, implementation. I don't think we should have that. Does that work? It does. So now we had the choice. Do we want to be weakly structurally typed or strongly structurally typed? Where strong structural typing has guarantees at creation time, but weakly structural typing allows us to add implementations. That is pretty cool. Just tidy up. Okay then, so I think what we've got here is the idea of an invocation handler, which is something that takes a number of parameters and returns anything, even null. The ability to take a map of method to invocation handlers and build a proxy of it, and then ways of building that map that compose. So we have structural lookup for, and we can additionally check that we found everything, and we have co-structural lookup for, which ditches continuations. This feels to me like a powerful set of building blocks for implementing interfaces, and we have at least finally implemented the thing we wanted 3 weeks ago. Now that I've got a new tool, it would be interesting to see whether that changes the way I program. We can find out together if you subscribe to the channel. Maybe like this video to tell me to carry on making them, and perhaps even support my work by buying a copy of the book that I wrote in that price called Java to Kotlin Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.